Okay, cool. Also, in terms of releasing, one of the things that Daniel probably had to do was create like a signing configuration. So there's a difference between whenever you compile, there's a debug APK that's built and a release APK. So there's two things behind that. One is that the release APK uses something called ProGuard, which what it does is it takes this final APK and it signs it. So in here, for example, I have this file that has a signature for this particular app that will be used for release. So you have to set that up when you release to the Play Store. And then the other part is that it does a lot of optimizations. It will try to reduce the amount of code, or for example, if you have code in your application that is not used, it will try to remove it and try to make it smaller. Okay, cool. So one of the things that came up that was really interesting that I don't think I did a good job explaining was this concept of code generation. Remember how I had a lot of issues with R and how it wouldn't generate? So, and then we also talked about reflection, which reflection for Java is where you can basically go and during runtime go and look back into your code and potentially generate code during runtime. So there's this really interesting topic about code generation. So things like R and BR. You guys remember what BR is from? Right, this is from the data binding, right? And this is just part of it. So what happens is this is generated during compile time, right? So code is generated for you. So this is all magic that Android provides for you, but I want you guys to be clear that what's happening is that when it's compiling, it is running an analysis on your code and then generating it during compile time, not during runtime. And then code generation during runtime uses the concept of reflection. So I just want to clarify that. If there's any confusion with that, please ask, or definitely bring it up during office hours on Saturday, and we can talk about it in detail. But one of the things that we experience, right, is that because this takes time, and like Android Studio is extremely fragile, R and BR sometimes might not be generated fast enough. We also see that potentially with Gradle as well, right? So Gradle and the entire setup and stuff, right? Okay, perfect. Okay, so the other before we dive into the assignments, one of the things that we did not cover were basically intents. So let's see if I can bring that up. Okay. So we'll just run through this really quickly. Does everyone know what an intent is used for?
To transfer data from this activity to another.
Cool. Yes, so that is one use case of an intent. Does anyone have another example of usage for intent?
Start call, make a call.
Make a call, right? So if you think about what an intent is, it's simply just a way of specifying something that you want to get done. And it could be solved by your own activity. It could also be it could be a request that could be fulfilled by another app. It could be fulfilled by potentially a service as well, something that's in the background. So yeah, basically intents are how Android activities communicate requests to not just other activities, but basically the Android operating system. Okay, and there's a difference between implicit intents and implicit intents. Does anyone know what the difference is? I'm going to start calling on people's names. Anyone know? Jessica?
Before I read about what's different, but I can't remember.
Okay.
Just, I can't remember.
Boo?
I can see in the slide.
Okay.
It's a explicit intent I use to open up another activity. So I understand that when we want to start an activity to meet our requirement, so that is explicit intent. And for example, if we use another app, like press the button and it will call someone, so that will be implicit.
Yes. So the difference is that, remember, like, you're communicating potentially with inside your app, or you're communicating with the operating system. So a great example of an implicit intent is sharing. You know how a lot of people have that share button? So that share button can trigger any other app to handle sharing, right? So you can have Facebook sharing, Twitter sharing, Instagram sharing. All of them can implement that they handle this sort of action, and then that's when what happens is, like, if there's only one app that you have installed that handles that particular action, then it will directly take you to that app. Let's say you only have Facebook installed. So let's say you have Facebook, Twitter, and Instagram installed, and you press it'll broadcast an action out and says, "Oh, whoever wants to handle it, please handle it," and then you'll show that little pop-up that says, "Okay, please select the app that you want to handle it." So think of an implicit intent as a broadcast out saying who can handle this general action, versus an explicit intent is saying, I know exactly who I want to have handle this action. Cool. Last thing that we have to go over is just the passing of data. So some of you guys use start for activity for results. So basically what you can do is you can put an extra in your intent and send that data back, right? Okay, so the other thing I have to cover is serializable and parseable. So does anyone know what Java serializable is? Okay, so what we're talking about here is actually, like, how do you pass data from one activity to the other, or through an intent, right? So
I'm not sure, but I remember serializable is for when you pass data and you don't want the data to be missing or miss some part, so serializable will make it stick and will not miss information.
Yeah, so it's almost like a form of compaction, right? So basically, usually you express, like, let's say I have a new object, right? Usually you're passing, like, a reference to that object, correct? So let's say I assign this to some variable. So assign this to x. So this holds a pointer to an object, right? In memory. In memory, right? And so the thing is that when you're dealing with multiple activities, you don't want to pass something in memory to it. You want to, like, basically put it into, compact it into data so that people can, like, reread it out. Because this reference can go away. This memory reference can go away, right? So you don't want to do that. So serializable, what it's doing is it's taking this and basically converting it into bytes. It's taking your object and converting it into bytes. And now when you pass it along to something else, they can take these bytes and read it back into an object, right? So you would, like, let's say this is y. Y is not equal to x, right? Because it's a completely new instance but it took this code and the properties inside of it and re-expanded it out, right, into a new instance. Does that make sense? Cool. So serializable. If you create a new class, say object, you have to extend serializable. You implement serializable, and then it will request for you to have this serial version UID, okay, that you have to specify. And we won't talk about how that works, but this is great because this is like built into Java, and you can use it to pass data between two activities using your intent. So you can see that we have a new user, we put an extra in, and then we started the activity. And then in our second activity, we can get the serializable extra and recreate our user out of it. Okay, and then serializable versus parseable. So parseable is specific to Android. It is a lot faster. That's the thing that you just need to know about parseable. It is so serializable uses reflection, while parseable is like something that actually is optimized for Android for storing data. Okay. So what you should know is parseable is about 10 times faster, but it's a lot of boilerplate code that you have to write to set that up. So if you are communicating something very small, like maybe 2 properties in your object, use serializable. If you're using something much bigger, like a huge amount of data, then try to use parseable. Okay? Cool. Sweet. So that's all we have to cover for now, and so we could just jump into lab. Any questions?